that we can start in time, because sir will be
Okay.
having other works. He has
Okay,
too
sir.
many
Done.
things actually to do. Right.
So without further delay, let us start our session 2 of day 2 of STTP phase 2 program. So I welcome Dr. A. VEERARAGAVAN sir, who is currently a professor in the Department of Civil Engineering at IIT Madras. He has over 4 decades of experience in teaching, research, and industrial consultancy. Professor VEERARAGAVAN received the Indian Road Congress Pandit Jawaharlal Nehru Birth Centenary Award in 1994, Indian Road Congress medals for his best papers in the year 1991, 93, 97, 2004, 2008, 2011, and IRC recommendation certification for his highly commended research paper in the years 92, 94, 98, 2000, and 2015. Professor Dr. Veeraragavan is a recipient of a UGC Career Award for Young Teacher and National Award for Promising Engineering College Teacher in India. He was awarded the Vishwakarma Award under the category Outstanding Academician, Technologist, Scientist, Innovator by the Construction Industry Development Council. Professor Veeraragavan has published over 100 research papers in journals and over 150 papers in conference proceedings. He has coordinated over 15 major research projects with a budget over 12 crores. He has co-authored 4 books on surveying, highway engineering, 11th edition is under print, highway materials and pavement testing, a 5th edition, and pavement drainage, theory and practice by CRC Press, Taylor and Francis Group. He is a fellow of the Institution of Engineers India and a fellow of International Society for Engineering Asset Management. He is a member of a highway research board, flexible payment, composite payment, road maintenance and asset management, and highway specification and standards committee of IRC. He is an independent director of 6 XPV road companies of L&T IDPL. Welcome you, sir, for the session. I just hand over the session to Dr. Veeraragavan, sir, to deliver his lecture.
So thank you, Shopna. Thank you,
Thank you,
Dr.
sir.
Rajan, for inviting me to deliver a talk in this STTP. So I'll present before you. I think I'll share my screen first. Oh, the screen is visible, right, Shopna?
Yes, sir. Yeah, sir. First slide. Alternate
Yeah,
design for highway payment.
right.
Clear, sir.
Thank you.
Yeah, thank you, sir.
So maybe good morning to all the participants. So what I
Morning,
will,
sir.
yeah, morning. So what I would like to share with you today morning in the next 60 minutes or so is on alternate designs for highway payments. I will take you over what are the choices, what are the issues and concerns when you design alternate payments, and how to predict the life cycle cost, and also not only for new construction, but also for rehabilitation of the payments. The first question arises at this point is that why alternate design? What is wrong with the current design? That is the first question that has to be answered here. Before I go to the details of why an alternate design, for your information, let me just show you that India has got nearly 59 lakh kilometers of the roads. Out of 59 lakh kilometers, national highways constitute only 1.32 lakh kilometers. State highways, 1.57 lakh kilometers. But majority of the roads are other roads, which constitute the rural roads also. So now, out of this, the national highways, even though they constitute less than 2% of the country's road network, carries more than 40% of the traffic. So you know pretty well that majority of the roads are bituminous roads. Few sections are concrete sections. Is that we can design? Is it possible to have any other design which will ensure the performance? So if you ask the agency, what is that you want? For example, you can ask GMR, you can ask L&T, you can ask any concessionaire, Ashoka Bilcon or Cube Highways, anybody you can ask. They will say, I want a design for a pavement such that my cost for the maintenance and rehabilitation of the road during the concession period of 20 years, 25 years, 30 years is the minimum. That is what he will tell. If you look at the road user and ask him, what is that you want? The road user will say, I need a good riding comfort. That's all I need. I am not worried what you are burying. It can be black, it can be white. I am not worried about that. The issue at this point of time is that when you design the pavement and construct the pavement, you are looking at the initial cost of construction. The question arises at this point, any design that results in lowest initial cost, will it guarantee a satisfactory performance during the design life or not? That is a $1 million question. Is there a relation between design and performance? Yes. Is there a relation between rehabilitation performance? Yes. Then why are you not considering alternate designs? So now we understood that initial cost is not the only criteria to be considered to ensure a satisfactory performance. I can add one more point. Now, the problem is sustainability. Are all the roads that we are constructing today sustainable? How long will they last? For example, a bituminous pavement is designed for 15 years or 20 years. Question is, what is that meant by design? What is meant by design life? For any structure, you can give a life, 50 years, 100 years, 200 years, you can give a design life. For a pavement, what is the design life you are talking? The pavement will not die, but we call this a design life. At the end of 15 years, what will happen? The road will reach a very poor condition. That's all. At the end of the design life, the pavement will warrant a major rehabilitation or a reconstruction. That is what we expect at the end of 15 years or 20 years. Okay. Just now I said, at the end of the 15 years, it warrants a major rehabilitation, a thick overlay. Is it lasting for 15 years? No. Why? Is the materials wrong? Is the construction procedure wrong? Is the mix design wrong? What went wrong? That is another area that is away from what I am talking. But I designed a pavement for a design life of 15 or 20 years. Now, many of the projects, NHA in particular, NHA projects, which are costly projects, the cost of a 4-lane highway will be around 10 crores per kilometer, 10 to 12 crores per kilometer. The cost of constructing 1 kilometer of a 6-lane highway may be anywhere between 15 crores to 20 crores. So when I'm spending this much of money, the question arises at this point of time is that I spend 15 crores, I construct a 6-lane highway, I design for 15 years. Will it last for 15 years without major maintenance? That is the $1 million question. No. Answer is no. Why no? What went wrong? Is the characterization of material wrong? Is the mix design wrong? Is the design process that are wrong? What went, or the construction quality is wrong? That is a $1 million question that has to be answered. The question arises I am posing before you is that, can I give you a better design which lasts longer? Can I use alternate materials, alternate technologies? Yes, that is possible. I will take you over what are the alternatives that are available for the design as well as rehabilitation of the pavement. The first challenge that we face in India today is that we don't get aggregates for construction. Perhaps in South India, we are fortunate enough. I would not consider Kerala to be very fortunate. There are issues of non-availability of materials for construction because of environmental other issues. But as far as states like Karnataka, Tamil Nadu, Telangana, Andhra Pradesh, the problem is not that severe. But if you go north, either go to Uttarakhand and beyond, or you go to the Bengal, or you go to Northeast, you don't have good quality aggregates. So you don't have the luxury of designing the pavement as you wish. So when the material is not available, what should I do now? Remember, we are not talking about the initial construction. We are talking about the future maintenance, future rehabilitation. So should I consider a design which lasts longer with a costly structure, or an alternate design which will last only 10 to 15 years? What should I do now? Now, if you look at the initial cost and design the pavement, it's quite possible that your vision is only 15 years, 20 years. But the concessional period for any road builder may be 25 years, 30 years. So he has to maintain the road for 30 years. Now, the question is that there are different forms of contract. Depending upon the type of contract, the road design procedure will change. There can be a case of new pavement wherein you can consider alternate materials, an existing pavement which has to be maintained. I will take you over what are the issues in the new pavement as well as existing pavement. If you look at a new pavement, I have a standard template of design, standard test procedure for the material, use the material characteristics for the design, and then construct the pavement. But can I have alternate materials? Yes, possible. Will it be better performing? Possible. Then how do I use that? That is the first question that has to be answered. The second question is that I have an existing pavement. I think this I always tell in a joking, in a lighter vein. If somebody is interested, somebody has got money. Now there are several road projects that are available for sale. Like buying anything, you can go and buy a road, existing road, which might have been constructed as per the specifications, but the concessionaire is not able to operate and maintain the road. He is not able to repay the principal and the interest. So now he wants to sell off the project and then go away. Now, if you take the project, buy the project, you have to value the road asset and then come out with alternate rehabilitation treatments which will take the road for the next design concession period of 15 years or 20 years. So for a new road, there are alternate materials, alternate design technologies. For existing road, there are alternate rehabilitation and maintenance technologies. We'll come to that issue. The issue is mainly when I have an alternate material, how guarantee are you about the performance? You say that for example, I am selling you a new binder. You are aware of the conventional binder that we use in India. You are aware that we use viscosity grade bitumen. It can be called as VG30, VG40 grade of bitumen. Now there are modified binders available. It can be a polymer modified binder. It can be a crumb rubber modified binder. It can be natural rubber modified binder. It can even be waste plastics modified bitumen, bituminous mix. Which one will perform better? I said, if you design as per the IRC, Indian Roads Congress specification, we expect a maintenance at the end of 5th year, maintenance, resurfacing, a major rehabilitation or a thicker overlay at the end of 10th year. Maybe at the end of 15th year, another minor rehabilitation may have to be carried out. So in a period of 15 years, I do one minor rehabilitation and one major rehabilitation. 15th year, I should hand over the road as it was given to me or like a new road. So the 15th year, I do a minor rehabilitation and hand over the road to the agency. Okay. Now I know pretty well if I design the road as per IRC, 5th year there's a maintenance, 10th year there's a maintenance, 15th year there's a maintenance. Now I am telling that use that another binder. Will that also warrant a maintenance in the 5th and 10th year? May or may not be. How guarantee are you? That is $1 million question. The issue is predicting the performance of the pavement. I would like to know how many times I should maintain the road in the concession period or in the design life. I am interested to know the second. Thirdly, what I find is that the quality of construction plays a very important role. That's why I always move away from those people who work in the laboratory. In the laboratory, for example, it can be finding out the optimum moisture content, maximum dry density, CBR of the soil, unconfined composite strength. You bring 1000 kg of soil or 2 kg of soil, 500 kg of soil, 25 kg of soil. From the field, you bring the soil, take 1,000 grams, do some testing, or 2.5 kg, you test the material exactly, 56 blue, 3 layers, test it, and then find the OMC and the maximum trade density. Or even take, for example, bituminous mixes. You take 1.2 kg bituminous aggregates, add 5% binder, 5.5% binder, exactly midpoint gradation, compact 75 blows, find the moisture stability value, flow value, and then find out the OBC. This is for 1.2 kg, it is okay. You are producing 200 tons per hour, 300 tons per hour. How are they related between lab to field? To what density are you able to compact in the field? If the density of compaction in the field is different from that of the density you get in the field, the so-called modulus value is different from lab to field. Now I predicted the performance based on my laboratory testing. But in the field, the density is different, voids are different, thickness are different, then the performance is also different. How do you account? How do you marry both theory to practice? So the constraint quality to the performance, according to me, matters a lot. So finally, whenever you create more and more length of infrastructure in the country, road infrastructure in particular, you have to preserve and maintain the road. So road infrastructure asset management will be the future of India. So there are different technologies, techniques, materials available. That's what I will take you over today. What are those alternatives that are available before us? So creating an asset is not a challenge. Preserving the asset, maintaining the asset, rehabilitating the asset will be the challenge, because everything costs money. And finally, proof of the pudding is in the eating. Finally, I need a good performance. What is that performance? How do you define the performance? We can define the performance in different ways. We can say in terms of cracking, we can say in terms of rutting, in terms of raveling, in terms of pothole, in terms of skid resistance, in terms of riding quality, in terms of deflection, many parameters you can bring in. But eventually, if you look at a road user and ask him, what is that you want? The road user will say, I want a comfortable ride. I want a smooth, fairly good riding quality. I want to travel at 100 kilometers per hour. So now, you as an agency are looking at the bolts and nuts, CBR value, modulus value, thickness design. You're talking about that. That is, and so that your cost of construction is the lowest. On the other hand, the road user, he's not concerned about what you're burying, what modulus, what thickness. He's not buried. He wants a good performance. So now the issue arises, how should we tender the project? Should I tender the project to construct a design pavement and then construct the pavement as per the design? My question is that if I construct a pavement as per your design, what is the guarantee that it will perform? My theoretical model says it will perform, but will it perform? May or may not be. So what I will do is that when I am not sure that my design will perform in the field, what I will tell you that I want a pavement. That's it. Such that cracking should not exceed 20%. Rutting should not exceed 20 millimeter. Riding quality in terms of bump integrated roughness or unevenness should not be more than 3000 millimeters per kilometer. That's it. You do whatever you want. You do stabilizer subgrade or natural subgrade, granular subbase or stabilized subgrade, polymer modified binder, unmodified. You do whatever you want. Now, there's a requirement of alternate designs. So when you consider alternate designs, when the materials are not available, what is the design? Say, for example, this is a World Bank report which says, if you consider the accelerated or high growth scenario, we require about 450 million tons of aggregates every year. Where are the aggregates? We require bitumen 4 million tons. We require cement 17 million tons. Steel 3.28 million tons. Leave alone steel, cement, and bitumen. Bitumen also is another issue. So the issue is that should it be a bituminous pavement? So the question arises at this point of time. Aggregates. 250 million tons of aggregates we require for road construction. So now I have an option before me. Two payments, two different designs. Which one will you perform? Which one will you consider? The one with the lowest cost or the one that will last longer with a little higher initial cost? So there comes the challenge of alternate designs. So if you look at the conventional way or procedure that we adopt to design a pavement, the pavement consists of different layers, starting from an embankment, a subgrade, subbase, base course, and the bituminous layer. So every layer is important. Every layer has got a different function. The subgrade is one layer that supports the entire pavement system. I always tell that there are people who work on bitumen. There are people who work on bituminous mix. There are people who work on granular material. So we look at the pavement as a material science. They say that you test the bitumen, pavement will perform better. They'll test a mix and the pavement will perform better. I always tell it is a system. Even if you put a steel plate on a clayey soil, it will not work. Therefore, testing the bitumen, you say this bitumen is better than that bitumen. I don't question. But don't tell about the pavement system by testing the material. I always tell that those people who do research on bitumen and bituminous mixes, that I say that you are not in applied mechanics department. You are not in chemistry department. You are not in chemical engineering department. You are in a civil engineering department. Civil engineer should look at the pavement as a system, pavement as a structure. We think that structure is only this structure is a slab and beams or structures, but pavement is also a structure. It has got number of layers. Each layer has got a different function. But only thing is that we are not worried about the cracking on the pavement because crack is below our feet. But if the crack at the top, we are worried because it may fall on our head. That's why we are spending more careful when it is a structure at the top of the head. But the cost implications of a failure of a road will run to several million crores of rupees every year. But nobody understands that. But the concept at this point of time is that the load gets distributed over a wider area. I don't require superior materials at the bottom, but the entire load is supported by the subgrade and the embankment. So if you want to have an improved long-lasting performance, you have to take care of subgrade and sub-embankment first. I'll talk about this again on Saturday about the long-lasting pavement. So I don't go into details about that at this point of time. But only one point I want to tell here is that if you can improve the strength of the lower layers, you can reduce the thickness of the layers. Simple. That's what I want to tell at this point of time. Conventional subgrade, we always stabilize subgrade. Yes, performance will be better, thickness will be lesser. In this pavement system, which I have shown here, nearly 40% of the pavement layer cost is from the bituminous layers. So if we want to reduce the cost of construction, reduce the thickness of the bituminous layer. Simple. So now my objective should link with what I said earlier slide. I want to reduce the aggregate consumption. Okay, stabilize the subgrade. Simple. I want to reduce the bituminous layer thickness. Okay, stabilize the base course. So it is possible. Now alternate designs are possible, which will result in improved performance, lesser aggregate consumption, and lower life cycle cost. That's what we are going to see today. So in a conventional pavement design, we consider the radial tensile strain at the bottom of the bituminous layer as a criteria relating to the fatigue crack. So the end of the design life, I told about the design life in the beginning. End of the design life of 15 years or 20 years, the crack may initiate at the 10th year, 11th year, 12th year. But it takes time for it to propagate. At the end of the 15th year, this will have alligator fatigue crack. That means design life has reached 20% cracking of the paved area will be cracks. Then the pavement life has reached. My question to all the designer is that if that analogy is right, if I construct 60 kilometers of road with a similar subgrade soil, similar material for subbase and base course, this 20% cracking should be for the entire 60 kilometers, 4 lane. No, it is not so. It is there for 1 kilometer, it is for 2 kilometers, it's not 5 kilometers. Why? What went wrong? What is it? Material is wrong or the design is wrong? That is the relating quality to the construction. My principle is that this is a critical factor that has to be considered, which is the fatigue at the bottom of the bituminous mix. Again, there are two layers in a bituminous, two different layers at the top of a pavement. One is the wearing course, which is a rut resisting mix. The second is a bottom layer, which is the fatigue resisting layer. So the bottom layer should resist the fatigue. The top layer should resist the rutting, even though both are called as bituminous layers. So the design philosophy for the two different layers are different. Don't say bituminous concrete I provide or HMA hot mix asphalt I provide. It will take care of both. No, you have to design them separately. But many researchers do a fatigue testing on what material. They'll say bituminous concrete. I always say bituminous concrete should be a rut resisting mix. Why are you testing it for crack resistance? This is again another area that has to be explored. So fatigue resistant is by the binder course. Rut resistant is by the wearing course. We also consider the vertical composite strain on top of the subgrade, and we think that this is related to the rutting in the layer. But the rutting can be due to excessive vertical compressive strain on top of the subgrade, or it may be due to the bituminous mix alone. If the design is not, or the mix is not proper, it will rut. That's why I say a rut resistant mix. The mix will shear off. So don't relate that mix problem to the vertical composite strain. But people do not consider this as a design. Third, many of the pavements constructed in India prematurely crack. So once you find a crack at the top, does not mean that fatigue crack. This is a top-down crack. Top-down crack causes are different, but unfortunately, we do not consider top-down cracking as a criteria in the design process. I do not know why. I think that should also be considered. That is related to the binder that you use, mix that you adopt, overloading, tire pressure, temperature, and other climatic factors. So one is structure related, other is other environmental and other material related. So, but all factors are to be considered if you want a good satisfactory performance. So what IRC has done is that considering these design parameters of radial tensile strain, keeping it within the allowable limit, and the vertical composite strain on top subgrade as the allowable limit, they have come out with a design catalog. They consider a granular subbase, a granular base, and a bituminous layer. They put only a bituminous layer in one basket. Just now I told this bituminous layer is not one layer, it is two layers. Or in fact, it can be three layers. Binder course and a wearing course. I can say lower binder course, upper binder course. Both are different. Gradations are different. Binder contents are different. Similarly, the wearing course is a different gradation, different binder content. So you can have a conventional subgrade, conventional granular subbase, conventional base course, a binder course, and a wearing course. This is option 1 before you. I can have an option 2, alternate design, with a cement treated subbase here. I can have a cement treated base here. So if I do this, I know pretty well that when I have a cement treated base, this cemented base will crack. I know that. At the time of design itself, I should know that this layer will crack. But if you provide a thin bit, because I have a stabilized subbase, I have a stabilized base, the thickness of these layers will be much, much lower than what I have here. So I have now reduced the thickness by stabilizing the subbase, stabilize base as well. Can I stabilize subgrade also? Yes. So the issue that you should consider at this point of time is that as the stresses coming at the bottom layers are much, much lower, if you want to improve the property of subgrade, the percentage of cement, I just give an example, cement, it can be any other stabilizer, maybe 1%, 1.5%. By improving the subgrade strength, the thickness of the pavement can be brought down significantly. So in this case, when you have a cement-treated base, cement-treated sub-base, you can reduce the thickness significantly. You may ask one more question. In this case, what I said is that in this case of pavement composition, the sub-base is a layer which is a drainage layer. Any water that gets in through the cracks, through the potholes, through the capillary rise, through the shoulder should be able to let out of the pavement. So this sub-base should be for the full formation width. Now you can ask me a question. You told about the cement-treated sub-base. Will it be permeable? You should consider both what I said just now. The stresses coming at the bottom layers are much, much lower. So I don't require a higher percentage or dosage of cement. So when you have less than 2% cement, we found the cement-treated sub-base is also equally permeable. So that question is addressed. Strength is better, with the result the thickness can be brought down. So in the case of structure 3, I have a subgrade. I have a cement-treated sub-base. I have got a cement-treated base. In lieu of the granular layer, I have come to the issue why granular layer. I go in for a semi-layer, stress-absorbing membrane interlayer, which can be bitumen-impregnated geosynthetic layer. All are crack retarding layers. I don't say crack prevention layers, crack retarding layers. They will prevent the crack from the concrete base from propagating to the bituminous layer. So what will happen is that it's a continuously borne material. With a repeated application of load, there will be a tension at the bottom, so there will be a crack that will form. So if you don't care of this crack will propagate and come to the top of the bituminous layer. But this crack is a phase 1. It will become more cracks under repeated loads. That is an effective fatigue phase. So eventually in phase 3, the layer will totally crack, and the modulus of the layer will be equal to a granular layer. Now, I have assumed 5000 MPa as a modulus. It has cracked. It has come to 3000 MPa. It has cracked. It has come to 2000 MPa. It has cracked. It has come to 1000 MPa. Now, I designed a pavement assuming 5000 MPa. Is it right? No. Then what modulus I should consider? Should I consider 1000? Maybe it was worthwhile. So these are issues or research areas on which somebody can work. How do you account this varying modulus value? What is its influence on the performance prediction of these pavements? So what South Africa did was that this crack will propagate. So they have provided a crushed stone base, which will serve as a cushioning layer between the bituminous layer and the stabilized base. So this will retard the appearance of crack. It's a crack prevention layer which can be adopted. So that is why IRC has come out with a granular layer above a stabilized base. You can also go in for a semi layer. They come out with the catalog 4, which can be a foamed bitumen emulsion, which can be treated with the old milled material. For example, you have a 2-lane road, old road, 20 years old, 15 years old. Now, I can provide an overlay above that, design the overlay. But what will be the life of that overlay? Will it depend upon the lower layers and their strength? Yes. Supposing the lower layer has got few layers of waterborne macadam, it does not have a drainage layer. What is to be done? In such cases, when aggregates are not available, you can mill the entire material, mill the whole bituminous layer. For example, if you look at Anna Salai, the thickness of bituminous layer in Anna Salai will be more than 30 to 40 centimeters. There is no meaning in providing a thicker overlay above that. I have to resort to recycling. So that's called as reclaimed asphalt pavement material, called as a RAP. Some cases, you can mill the old bituminous layer with a old granular base, and then you can mix them with foam bitumen. To hot bitumen, you inject air and water. The volume of bitumen will expand to maybe 10 to 15 times. It will spot weld the milled particles, and that can be used as a good base course. We did this for the first time in Chennai Tada. Anybody who's interested can visit Chennai Tada section. between kilometer, I think 21 to 33 or something. You can check the grade. I can get you the details of the chainages. Was constructed in 2011. 9 years have passed, no cracks, no rutting. Based on this, we developed the IRC 120, which is for the recycling of the pavement. So another option, alternate design, is using the wrap. Option 5 can be above the cemented base. You can have below that you can have a granular subbase. Instead of having cement treated subbase, you can have a cemented base, an aggregate layer, and a bituminous layer. You can also go in for a choice of a cemented subbase and a wet mix macadam. So the bottom line is that pavement design, there is nothing like a single design. There is nothing like a one size fit all design. You may have to consider soil availability, aggregate availability, machinery availability, capability of the contractor, and then design alternate pavement sections. Then you should be able to predict how each of these will perform and select the one that will have the lowest life cycle cost. So IRC has given a fatigue model, which say there are two fatigue models, one for highways with 90% reliability, other for low volume roads with 80% reliability. So they given resilient modulus. This is what I contested at the beginning. These resilient modulus are based on laboratory models. Laboratory midpoint gradation, optimum binder content at exactly 35 degrees, test it and then get a model. But in the field, the pavements are subjected to different loads at different temperatures, different density, different compaction. The performance is different. So this fatigue model may not truly represent the field performance, but still for design purposes, you can have this fatigue model. Similarly, IRC has come out with a rutting model. So it again says 20 millimeter as the allowable rutting up to 30 MSE, and 10% of the length of the section can have this much of rutting. Again, they have given a rutting model as per IRC 37 2018. They given again two equations, one with a higher reliability, other with a lower reliability. Well, so they consider rutting in this equation. You can find number of repetitions is related to the vertical compressive strain on the top of the subgrade. It also says rutting in the bituminous layer also occurs due to the secondary compaction and shear deformation apart from that of the subgrade. So you have a rutting 20 millimeter. What is the contribution of the bituminous mix? What is the contribution of the subgrade? This is something that one has to study. Whoever wants to do a research has to separate it out. But majority of the rutting that I have observed on the Indian highways, they are due to secondary compaction problem with the bituminous mix. If the gradation is wrong, binder content is wrong, or binder type is wrong, how do you account it? Is another $1 million question. So if I use a modified binder, will it perform? May perform, but again, we need a different fatigue model. So cracking, there are models, there are rutting, there are models. We can go in for cementitious subbase and base courses. You should know ED cementation material normally crack due to shrinkage, maybe due to temperature changes. So we have to find the elastic modulus for the design is much, much lower than the respective laboratory values. How much lower? I told 5,000 MPa. Today consider 1,000. Today consider 750 MPa, 500 MPa. What value? Again, when you want to predict the performance, you have to predict the performance in different phases. Phase 1, phase 2, and phase 3. In phase 1, modulus may change from 5,000 to 4,000. For phase 2, it may change from 4,000 to 2,000. Phase 3, it may change from 2,000 to 1,000. So you have to consider a stepwise deterioration model rather than having a single model for 15 years or 20 years. Again, in addition to the radial tensile strain at the bottom of the bituminous layer, you should also consider the radial tensile strain at the bottom of the cementitious base also. So the IRC has again give a fatigue equation. It considers the elastic modulus of cementitious material, It also considers the reliability factor, 1 for expressways, 2 for other highways, and epsilon T is the strain tensile strain in the cementitious layer in microstrains, which means you should also know to test a beam of a cementitious base in the laboratory, find out at what strain value it fails. So, but always remember at the back of your mind, field compaction, field density is different from that of the laboratory density. So will I be able to get the same strength is $1 million question. So performance shift factor between laboratory performance predicted value to the field should always be considered here. They also given a fatigue equation. They consider a cumulative fatigue damage analysis, which means you should consider the fatigue life in terms of cumulative number of axle loads, which means again, I need the spectrum of axle loads. What percentage of vehicles, trucks are overloaded? More and more the overloading, lesser and lesser will be the life. So therefore, in the case of a cementitious basis, you should consider the cumulative fatigue damage considering the equations that are given by the IRC. So you have to consider the fatigue life of the cementitious base, fatigue life of the bituminous layer when you consider the performance of the pavement. Now that is one side of the story. Bituminous pavement, there are different alternate designs that are possible. Now let's jump over to the concrete pavement. We say concrete pavement. What is the concrete pavement which I am talking about? This concrete pavement can be a jointed cement concrete pavement. The concrete pavement can be a continuously reinforced concrete pavement or CRCP. It can be a fiber reinforced concrete pavement, FRCP. It can be a roller compactor concrete pavement. It can also be an interlocking concrete pavement blocks. Anything is possible, which again means if somebody asks you to design a concrete pavement, you have to ask back the question, what concrete pavement you are talking about. You have to consider which of these types will perform better. Again, my favorite quote, there is nothing like an one size fit all design. You should assess the situation, traffic, climate, soil type, constructability issues, and then come out with a design. Also, it depends upon the size of the project. 100 kilometers project, design is different. 1 kilometer project, design is different. No contractor will come to construct 1 kilometer of a CRCP pavement. There may be issues in constructing a roller compactor concrete pavement for highway, because riding quality will be an issue. But will it be sustainable? Yes, most probably yes. So depending upon the type of the highway, depending upon the category of the road, subgrade soil type, material availability, traffic, climate, and other factors, you have to choose the appropriate type of pavement. In the case of jointed plain concrete pavement, we have double bars, we have tie bars. So normally, we have a slab, normally, nothing like a fixed rule. Normally, one lane of 3.5 meter is one lane. We cut the slabs at maybe 4.2 to 4.5 meters. Wherever you have a contraction joint, we provide a double bar. At the end of the day's work, we have a full depth joint. So assuming that we want to have a concrete pavement, the concrete pavement will warrant a grade of not less than M40 for highways. Even for rural roads, M30 grade of concrete is required. And the thickness of the concrete pavement can be a case, I think I forgot is a white topping. White topping is also bituminous concrete pavement or a world bituminous pavement. But in the case of a concrete pavement of M40 for a highway, the thickness requirement will be above 30 centimeters, 300 millimeters, 330, 350, 360. Can I reduce? Yes, possible. How do you reduce? The edge load stresses causes more distresses or more severe. I can go in for a wider shoulder, a concrete shoulder. If I extend the width of the pavement from 3.5 to maybe half a meter either side and half a meter either side, or 1 meter either side, then the edge load stresses are reduced. With the result, thickness can be reduced. But thickness is reduced, but increasing the width. By increasing the width, you are increasing two more joints because the longitudinal joints should continue. So one has to work out the cost economics of having a 35 centimeter thick concrete pavement with 7-meter wide, vis-a-vis 27-meter wide pavement with a paved shoulder, which is economical with two joints, three joints, which is economical. That has to be worked out. Performance are different. Performance has to be predicted. So that will joints or dowel bars, there will joints or transverse bars will be there. This is for conventional manual construction, but with slip form paving, there are automatic dowel bar inserters which will insert the dowel bar exactly at the same depth. There is no need for chairs as you are seeing in the right side photograph. We can also go in for jointed reinforced concrete pavement, wherein you can have a skin reinforcement. This is a welded wire fabric reinforcement mainly to take care of the thermal cracks, nothing more than that. It does not add strength, it does not add anything to other than this. But thermal cracks will be lower. So, but generally, we don't go in for this reinforced concrete pavement. JR3P is not done. Either we go for jointed plain reinforced concrete pavement, or you can go in for a continuously reinforced concrete pavement. So in the case of continuously reinforced concrete pavement, there will be joints. There can be typical cracks, minor hairline cracks may occur at 0.8 to 2 meter intervals. There will be a tie bars again are required. This is how the reinforcement is for a continuously reinforced concrete pavement. Advantages: no joints. Joints are the bottlenecks, are the problematic locations in a concrete pavement. More the joints, more the problem, more noise, more discomfort. You want to have a smoother, whiter pavement, concrete pavement? Yes, go for the RCP. But reinforcement is an issue. You have to consider the reinforcement, you have to design it. But you can definitely guarantee a satisfactory performance in the case of jointed reinforced concrete pavement. It's possible here. The issue at this point of time is that the pavement, will it last for 30 years? May or may not be. Why may not be? Because distresses can be material related. There can be cracks, mainly related to the material durability issues. There can be structural distresses. You have not provided the joints at every 4.2 meters, 4.5 meters. Then the crack will form exactly at 4.2 or 4.5. Or these joints should be cut to 1/3 the depth using diamond cutters between one day to second day. If you delay it, the cracks will form randomly. That's again another issue. Third is related to the construction foundation support. If the foundation is not uniform, there will be settlements. Once the concrete settles, it is very, very difficult to jack up the slabs, do a grouting, and put them back exactly the same profile. So that can be a problem. Concrete does not mean, that's why I said, even if you put a steel plate, it may not last unless you take care of the supporting layers. So distresses can be because of material related, structural design related, or a support condition related. So in a nutshell, whether it is a bituminous pavement or a concrete pavement, it is a system as a whole. Don't test, mixed design is one of the components. Structural material is one of the components. Design is another component. So all of them are not independent. You have to marry all these for the system to perform. So don't test the binder and then say predict the performance of the system as a whole. Don't test the mix and then tell about the performance of the system as a whole. Unless you take care of subgrade and its compaction, subsurface drainage, mix design, binder quality, you cannot guarantee the performance. So it is a combination of materials, mix design, structural design, and construction activities, and that will ensure a long-term satisfactory performance. This has to be considered here. I think it's time that we should also look at precast concrete pavement. So in the case, this is something new. I think, according to, I always tell, tonight when I see there should not be a road, tomorrow morning when I come, there should be a concrete pavement. Is that possible? I think we are moving in this direction. I think we should move towards a precast concrete pavement, which can ensure satisfactory design, good quality control, curing, and you bring it to a site and assemble. When we can transport bridge decks, why not we transport the precast concrete pavements? So precast concrete pavement will be the future of India. They can bring it to site, assemble them, post-tension them at the site. It is possible here. This is an example of the precast concrete pavement done at Nagpur. And currently it's being in progress. They are casting it from site at some elsewhere, the casting yard, bring it to the site, and you can see in Nagpur, like Outer Ring Road, they are constructing a precast concrete pavement. The future is on alternate design. From the conventional design of a jointed plain cement concrete pavement, we will move over to the precast concrete pavement. So alternate pavement types depends upon it can be bituminous, composite, or concrete. We have to consider alternate rehabilitation technique. We should consider the life cycle cost. We also should consider sustainability issues in construction. Now, the projects are being tendered in different format. Earlier, we were doing the build, operate, and quantity, build, operate, the BOQ, bill of quantities we worked out. Then we tender the project. Then the contractor used to blame the designer. Your design is wrong. We used to blame the contractor, your quality is bad. So that was going on earlier. Then we got into the EPC contract, engineering, procurement, and construction. The contractor can design of his own. So we got into the design, build, operate, transfer basis. You go, you investigate, you construct, and you operate. So you cannot blame me that my design is wrong. So in case of new construction, for all NHDB projects, we have brought in a DBOT, design, build, operate, and transfer. On the other hand, we have projects, as I was mentioning, road for sale, existing road. You have to maintain and operate. That is toll, operate, and transfer. Well, already constructed road is available. You have to maintain and operate for next 15 years. So you have to value the road asset, estimate what alternate maintenance treatments, and then design and construct the treatment. So you have to salvage, save the material, reduce the resources, and then construct the payments. So there are possibilities of having a higher modulus in this case when comparing to the conventional gravel. So I was mentioning you can go in for a stabilized subbase, which you can also have modified binders which can withstand higher strains. Is it possible to reduce the strain values? Yes, these pavement design thicknesses will reduce the design thicknesses significantly. Will there be reduction in the asphalt layer thickness? Yes. Will it result in pollution? Yes. Will it result in saving in cost? Yes. So we should move towards a sustainable pavement materials, sustainable design by having alternate designs. You can also recycle the materials, which you can add up to 30% of the reclaimed asphalt pavement materials as wrap in a hot mix. You can have up to 50% of the wrap in cold mix. In the Chennai Tata section, 100% of the wrap has been used. It is possible to use entire reclaimed material in pavement design, in construction. So the future of India, or not only India, around the world is salvaging the already constructed pavement, saving the material, reducing the aggregate consumption, and ensuring a satisfactory performance. Even in the case of rural roads are awfully bad. Again, you can do a full depth reclamation. I can mill the old waterborne macadam layers, a part of the old premix carpet layers. Entire metal can be milled. I can add a cement and then stabilize that layer. So I am salvaging already constructed pavement materials. I am improving the strength. With the result, I am making use of the 100% of the material that is already buried. I am providing only a thin bituminous layer at the top. Will the pavement perform? Yes, definitely. So salvaging, saving the virgin aggregate, reducing virgin aggregate consumption will be the mantra in the years to come for sustainability. If you consider alternate designs, a conventional design, for example, for a traffic of 50 MSA, 10% CBR, you can find that 40 millimeter BC, 105 millimeter dense bituminous macadam, 250 millimeters of a wet mix macadam, and 200 millimeters of granular surface. The aggregate consumption 15,000 metric ton for a 2-lane plus a paved shoulder. Cost 2.46 crores per kilometer. I can have a composite pavement I can reduce the thickness of this bituminous macadam from 105 to 60. I am trying to stabilize the subbase and the base. Aggregate consumption 13,636. So nearly 2,500 metric tons of aggregates per kilometer I can save. Cost approximately similar to that of the conventional pavement. Will it perform better? Definitely. That's what. How do you say definitely is another question. I can design and demonstrate that design is better. Strain values are lower. I can also go in for a concrete pavement, which can give a life of 30 years with a lower aggregate consumption of 12,935. Bit costly, 3.223 crores, which is better. Now you have alternate designs. One with a 2.46, one is a 2.44, other is 3.23. Which of the three will perform better? If you have money, go for concrete. You have less money, when you have to choose between conventional design and the composite, I would bet on composite pavement. Exactly this is what we are going to try in Karnataka for the Karnataka Road Development Corporation. I'll come to that issue. But you should consider alternate pavement designs. Simple. I want to improve the subgrade. So what are the issues? By improving the subgrade from 5 to 10 CBR, as per the IRC, you can reduce the thickness of the bituminous binder cores from 140 to 105. From 3.2 crores, you can bring down to 2.91. Is that optimal? Are there any other designs? Yes, I can further reduce. How do you do that? I will not have this 250 millimeter piece macadam. I'll reduce it to 150. How? I can use the geocell. 200 millimeter GSB required? No, I can bring down to 150. So I can further reduce the cost by stabilizing a subgrade using alternate materials. I think the future is on considering alternate materials. Rural roads. I have a conventional design with 135 millimeter of a granular subbase, 150 millimeter of waterborne macadam. I mill the entire material, add cement, and then have just a base course, stabilized base. So I provide the same bituminous layer. You'll find that from 2,365 cubic meter of aggregates, I can bring down the requirement of aggregate to only 252, 1/10. So there is a savings of 6.5% in the cost. So the future is on recycling, reusing the material, and reducing the virgin aggregate consumption. This is a photograph of the road before, this is a photograph of the road here. So this road will last for next 15 years for rural road without any major maintenance. I think this is something that we should look for. I can use geocells in road pavements for construction. It's an extruded polymeric material like HDPE. So this is work that we did at Maharashtra in a Gobind dairy. Milk tankers with 12 tons, 12,000 liters will come. So when there are trucks of 10, 12 tons ply, the road was slushy. We suggested go for geocell, stretch the geocells, fill that with aggregates, compact. What are the advantages? I can use the IRC conventional design, thickness required is 975. I use a geocell only as a subgrade, thickness reduction is possible to 735. Use a geocell in the base, I can reduce thickness to 520. Only the base course 865. So from 975, I can bring the thickness to 520 by using a geocell. So this lasts for 16 years, this lasts for 20 years. If this costs 2,635, this will cost 2,450. Even in case of high CBR, instead of 650 millimeter pavement thickness, I can bring down the thickness from 650 to 340 using a geocell, using both in the geocell in the base and subgrade. If this lasts for 15 years, this can last for 20 years. So the future is on use of alternate materials. Instead of stabilization, I can use even a geogrid. I can improve the strength and hence guarantee you the performance. Earlier, you can ask me, why were you not adopting all these years? We were not having a code of practice all these years, so we were not adopting. Now, IRC SP 59 is on use of geotextiles, geosynthetics in highway pavements. You can use that, refer it, and then design the pavement like this. Even coir can be used. We tried for rural roads. Coir has got a function of separation. It has got a function of filtration, drainage, and as reinforcement. There are two different types of coir available, different GSMs For a rural road, we are constructed with a coir, and we found that if you can have 700 GSM or 400 GSM, you can bring down the thicknesses, say 175 plus 150 to 125 plus 150. So I can bring down the thickness by 50 millimeter here. I can bring down from 175 to 150 here. So it is possible to ensure sustainability in low volume roads using coir. You can also use jute also. Other applications are water erosion control using coir. Grass will grow. You may ask me a question. Will it not be biodegradable? Yes, they are biodegradable. But we found after 6 to 7 years, they are not that much biodegraded, but they impart the strength in that process with the result performance is good. Alternate designs, we should consider the alternate designs of life cycle. Economic analysis procedure, we compare alternate designs, for the results in equivalent rupees. So you consider only the initial cost. The current method of tendering is that if there are 10 bids you have received from 10 different contractors, whoever quotes lowest L1 only will get the design, will get the project. But my question at this point of time is that maybe that another contractor who has got 20% more, will that not be better design with an improved performance? Yes, that is also possible. But the current system contract does not encourage that. We need to bring in weightages for like this green rating of buildings. We have to bring in green rating of highways, alternate technologies which are sustainable. But what are maybe the initial construction? The pavement will warrant maintenance every year. That is the routine maintenance. Even though you do a routine maintenance due to wear and tear, they require a minor rehabilitation. So it can be thin overlay or a thick overlay, depending upon the deterioration of the pavement. There's always a salvage value at the end of the life. If you bring in different pavements of different design will perform differently. The year in which they need a rehabilitation treatment will change. So accordingly, you have to bring back the cost a base year and compare that is the present worth of cost. For example, you can find that the cost keeps on increasing year after year depending upon the design. I can have design A, which warrants maintenance on the 11th and 22nd. Design B, which warrants maintenance on 9th, 18th, and 22nd, 7th. Third, it warrants 8th, 15th, and 23rd. Fourth, only one maintenance of 14th year. Fifth, 10th, and 21st years. Now I have 5 alternate designs, which is better. If you consider the cost, these are thickness values for alternate designs. If you consider initial cost, design D, which warrants only one maintenance is the costliest 83.5. Because the present worth of the overlay cost. Some will warrant 2 overlays, some will warrant 3 overlays. These are the overlay cost. These are the maintenance cost. Because you're closing the road, there will be extra user cost due to overlay operations. If you look at the maintenance cost, these are the present worth of maintenance cost. This is the extra user cost due to speed reduction because of frequent maintenance. This is the cost of the present worth of salvage return. I put all of them in one basket and now compare the 5 alternate designs. You'll be surprised to know, even though the initial cost is more, 63, this is 83. But at the end of the life, you'll find that the design which warrant only one maintenance is the sustainable, long-lasting, lowest life cycle cost. I think this is the future of India, wherein you should consider alternate designs and come out with the cost-effective design. Similar rehabilitation, a pavement will warrant maintenance different time periods. For example, maintenance can be preventive or it can be corrective maintenance. There are different choice of treatments again, fog seal, slurry seal, microsurfacing as a preventive maintenance, which can be done when the pavement is in good condition. But we don't maintain this. We allow the road to deteriorate. The cost of maintenance goes up and up and up. And it is like new construction. If it costs 10 crores here, it may cost 1 crore here, minor rehabilitation. If you delay it more, it becomes 10 crores. If I do it here, the performance is better, like a new pavement. Why are you not doing that? And this is something that we need to develop, the concept. So preventive maintenance, different alternatives. Alternate binders are available. Different mixes are available. Recycling, again, can be cold or hot. It can be in situ or a central plant. So alternate rehabilitation treatments are possible here. For example, this is an existing pavement, which is cracked. I can provide an overlay above 140 millimeter dense bituminous macadam and a bituminous concrete. Alternatively, I can mill the material. As I said, within Chennai Tada, this is a bitumen stabilized material. So this material I am using it here and then providing BC. So you'll find that the cost per kilometer is 116 lakhs. Cost per kilometer is only 95 lakhs. Aggregate consumption 3,400 tons per kilometer, only 1,180 tons per kilometer. So alternate design with recycling, reusing the material and rehabilitating the material will be much better than providing an overlay over an existing deteriorated road. A simple case of a conventional design with a CTSB, say cement treated subbase, you'll find that around 3,000 metric tons or 2,500 metric tons of aggregate can be saved by providing a cement treated subbase, also using a reclaimed asphalt pavement materials. So the future is on reduce, reuse, and recycle. That is the mantra. If you consider the cost economics of cement treated subbase material, we found that we can save nearly 60 lakh rupees for a 4-lane highway by introducing a cement treated subbase. So in the case, for example, this is a road which has to be rehabilitated. What should I do now? You have got a different option. This pavement has already cracked, as you are seeing here. What are the options? So option 1, I will try to patch. Mill only the top 75 and patch it. I do this patching. So after that, I provide an overlay and 30 millimeter of ultra thin friction coats for 30 million standard axles. Cost of this will be around $30 per square meter. Option 2, I'll mill the entire bituminous layer and then rework on the base coats and provide a bituminous overlay. For this 30 MSA, the cost of this will be nearly $45 per square meter. I got option 3, wherein I mill the walled bituminous and the granular base. I provide a cement treated base and I provide a bituminous layer at the top after providing a granular layer of 150 millimeter. The cost of this will be $42 per square meter. Option 4, I mill the entire, this is what Chennai Tada. Bituminous layer and the granular layer, mill this. It is a bitumen stabilized material. Over that, I don't require 75 millimeter bituminous layer, just 35 millimeter bituminous layer will be adequate. Maybe you can provide a 30 millimeter ultra thin friction course. Cost of this will be the lowest, $24. So even while rehabilitating an existing road, you should consider alternate designs and then come out with the design. So summary, the one with the lowest will be the one wherein you recycle, reduce, and reuse the materials. This is a road of a KRDCL project, which I am now currently working on, which there are different alternate designs for 20 million standard axles. So you can bring down the thickness, say for example, 200 plus 250 plus 130. I can bring the thickness significantly by providing a cement treated subbase. I can have reclaimed bituminous material with 50% wrap. I can have for the DBM 30% or 20% wrap can be used. So we want to compare alternate designs and then study the performance. We find nearly about 40% savings is possible by adopting alternate designs. So the future of India is on recycling of the materials. So to sum up, the cost, one more before I say, the cost comparison of the rehabilitation, 2 options, 4-lane highway, mill and replace with a full depth. I think the cost of this will be nearly, I think, 2 crore 83 lakhs. Mill, replace, and a full depth as one layer, DBM and ABC. Alternatively, I go in for a cold in-place recycling with a foam bituminous mix. You'll find that the cost of this will be 2,11,000. We compare the cost of both options from 2,84,000 to 2,12,000. Nearly 71 lakhs you can save per kilometer by adopting a recycling technology. So coal recycling offers nearly 25 to 30% reduction in the cost, ensures 100% reuse of the material. Being coal process, no heating, environmental pollution is not there. greener and natural-friendly recycling technology is what you should adopt. So to conclude, the immediate need is to consider alternatives in new construction as well as in rehabilitation of the pavement. This will reduce, reuse, and recycle the material and will conserve the natural resources. Alternate designs will definitely ensure a satisfactory performance or a better performance. Challenge only predicting the performance of the pavement. Here comes the mechanistic empirical pavement prediction models, which can take care of alternate designs. There's a need to change the contract conditions. You should not be based only on L1. You should give weightages for the savings in aggregate consumption, improved performance, lower life cycle cost in the tender evaluation process. Involved benefit to be accounted in the project evaluation. Again, there is no one-size-fits-all design. Depending upon the subgrade soil, traffic, climate, environmental conditions, and the constructability issues, you have to choose the appropriate design for the appropriate project. And that's what I want to tell at this point of time. I think I have exceeded by 7 minutes. I'm sorry about that, but if any questions, I'll be happy to answer.
Thank you, sir. Thank you so much, sir, for your valuable lecture. So participants, do you have any question? You can just raise your question in a chat box so that sir will clarify your doubt.
And there are no questions as of now. Or anybody wants to ask also, and unmute and ask.
Yes, you can unmute your mic and you can ask one by one.
Yeah. You can raise the hand or else to avoid a problem. Any questions from you?
Good afternoon, sir. I'm Dr. Bala from St.
Yeah.
Perhaps you remember we both went once to Pondicherry for a Pondicherry bridge.
Yeah. Right. Yeah. Right. Yeah.
Long back.
Yes,
Okay.
Right.
Remember that. Thank you, sir.
Thank you.
Now, you see, you have mentioned about the change in the contract conditions.
Yeah, correct.
So, what is the existing condition? Because we see, if I look at it from my area in a pile foundation design, alternative design for a pile, they have been totally stopped. We hardly submit any alternative design these days. Right. Now, highway roads and highway projects and things like what sort of an alternative design you can, so you try to put it in the tender condition, and what is the existing tender conditions now?
Existing tender condition is only L1 will be the project.
Right.
Now I want to change that. I want to consider the life cycle cost in selecting the project. That's it.
Okay.
Now I think 14th yesterday, the ministry has issued a circular on use of new materials.
Okay.
So that now all these years we were not considering alternate materials. Now alternate materials design is possible. Then the government will take a decision. All this time it was not possible. Now it is possible with the new code that new circular that they have issued yesterday.
Correct, sir. But then there will be, if each contract will have a certain section length, is it not? It is not that supposed
No.
to.
Yeah, go ahead.
Yeah. Now, do they give the complete geotechnical data, traffic, your traffic intensity, road density, everything? Do they give all the details for doing the alternative design?
No. That's why I'm asking you to do all the everything and then come out with the design. So I'm throwing the ball back in your court. You do the design so that you don't blame me. If I tell the factor, then you say your traffic factor values are wrong, my values are right. So that contestant will come. You'll contest. I say you do the survey. What you do is, say for example, the one problem is that we don't give adequate time for the investigation. With the result,
that is
we again the cost cuttings for survey investigation everywhere we cut. And we have to give only 30 months for the construction, irrespective of the length of the road. Right. So with all this coming into picture, it's a real challenge to ensure alternate design will perform. But that's why Karnataka Road Development Corporation has taken a new construction using alternate designs given by us. We are going for the alternate design. If it works, then we will permit alternate designs in the road construction.
But who gives the geotechnical data, sir? Because
Because every consultant decides. Nobody gives.
the basic data, see, end user should give some assumption.
Yeah. Yes, they will give. They will definitely give. Say for any the final initially a feasibility report is being prepared by the consultant.
Correct.
Right. Based on the feasibility report, the project is found to be feasible.
Yes.
Then they give the detailed project report preparation. So the DPR consultant is expected to do all this: survey, investigation, report preparation. Based on which the third phase is the tendering.
Okay.
Yeah.
Fine. Thank you, sir.
Yeah. Any other question for anybody?
Thank you, sir. I think the question is raised from Ranganath Kanta, sir. Can you able to see or
How can we
you
control the gradation limits in the wrap material? I don't think you can control anything. The thing is that you should take into account the various samples. Sample in the sense, if you want to know finally what is the gradation of the wrap. The wrap gradation will vary depending upon the different layers that were constructed over a period of time. So what I would suggest is that sampling plays an important role. So take, if depending upon 60-kilometer road, I will say at least 20 coarse samples I will take. Then check the variation between the samples and within the samples. Then I fix the gradation. So now IRC 120 will tell you the desired gradation. So once you know the gradation of the wrap and an average of all the samples, then you can fit into what gradation sample percentage you can adopt. There's nothing like you cannot control the gradation of the wrap. As it is, you have to consider, and you can only decide the dosage of wrap that can be considered depending upon the gradation available. Other case, which fiber is most useful for compressive soil for subgrade stabilization? Kindly share your full percentage. My percentage will be shared. But I think these are issues with respect to the fibers is that how do you mix it at the site? How do you ensure homogeneity? These are the issues that will come into picture. Therefore, that's why I'm suggesting I would prefer to go in for a geogrid rather than trying to mix the fibers at the site. The fiber, the aspect ratio of the fiber, the thickness of the fiber, the dosage of fiber, many things comes into picture. Again, nobody will be able to answer your question, which fiber is best suited. Again, I repeat the same. There is nothing like a one-size-fits-all design. The design has to be made by you, but in the laboratory, you can do by hand, mixing it uniformly, all that you can do with 1 kg soil. But when you're constructing 50 centimeter thick layer, 500 millimeter thick subgrade, for a formation width of 25 meters per a kilometer, compute the quantity of material. How do you ensure uniformity in this one? What are the benefit that you get by adding the fiber? Is a question. Instead, I would try to do mixing with either cement or a lime or any other stabilizer in a pug mill, ensure homogeneity of the mix and construct. But I cannot say that I don't say the fibers will not work. Fibers may work, but that has to be done by the laboratory. But laboratory will work, but how do the constructability issue is something that you should address. Hill roads are mostly roads of up and down. Which technique is used to control the distresses? I think hill roads are there everywhere. I feel that most of the hill roads are both are there. Bituminous are also there, concrete are also there. If you want to see the concrete road, go to Shiradi Ghat and see. Excellent concrete roads have been constructed. But most of the hill roads are bituminous. Only thing is there can be a more wear and tear. Secondly, hill roads, the rainfall may generally be higher. So what I would prefer, maybe use a modified binder, SBS modified binder. Then the deterioration of the layers to address the wear and tear, moisture-induced damage will be lesser. So the conventional bituminous pavement can take care of the wear and tear of the bituminous pavement. The bituminous pavement may be adequate even for a hill roads. Any other question?
So I think that's the question, it seems, sir.
Yeah.
Thank you, sir. Thank you very much, sir.
Thank you very much. Yeah. Yeah.
Thanks a lot, sir.
Yeah.
So participants, kindly fill your feedback, which is posted in the chat box.
I sent the feedback link for all the 2 sessions, Shobana, both. No?
Present session only have been sent, sir. So now we will be sending for morning session and afternoon session too.
Both you sent, please.
Yeah, sir.
Okay. Otherwise, also, if you have any doubts, questions subsequently, you can send me an email. I'll be able to answer your questions. Need not ask
Yes,
now.
sir.
We can
If
think over.
somebody, yes, sir. If somebody
I will
posts
also
the,
share the presentation. I'll also share the presentation to Rajan. Rajan will share with you. Based on after going through the presentation, if you have any further doubts, you can post the questions to me directly. I will be able to answer the questions.
Sure, sir. Thank you, sir.
Yeah. No, my email is not. I think Rajan will tell you. In my presentation, the slide is
Yes,
there.
sir.
No, my presentation has got this.
yeah, it is there.
Yeah, yeah. My email ID is in my presentation. Yeah.
We will do it. We will share the record. We have sent all the presentation. Don't worry, sir.
Yeah. Yeah.
Yeah.
Sure.
Somebody has asked for the PPTs. I have answered. Rajan, sir.
Yeah. Sure.
Thank you, sir. Thanks a
Thank
lot,
you
sir.
very
Thank you. Thank you very much, sir.
Thank you.
Have a great day.
Thank you, sir. Thank you, sir.
Thank you. Bye.
Bye, sir.
Bye.
So participants, it's a time for a lunch break and we will be meeting for the last session of the day 2 by Krishna Prapurna, sir. So at 2 p.m. sharply, we will be starting the... We will be
Dr.
starting
Krishna Prabhurna, faculty, professor from IIT, Tirupati.
Tirupati. So we will be meeting for at 2 p.m. sharply. So kindly please available sharply at 2 p.m. for the last session of the day 2. So before leaving the session, kindly fill your feedback in the feedback link. So we will be posting again for the morning session and the current session too. So thank you all the participants.
Yeah, let us meet by 2 p.m. Sharply, please join back again. Thanks a lot.